So let's start by the beginning. So who am I? So as you can guess by my accent, I'm not coming from here. So that will be in English, but with a French accent. Otherwise, it's too easy. If you don't understand something, feel free, ask me to repeat. I won't take it personally. I'm used to it. I'm 30 years old, so I heard that many times already. I work at Isovalent. I'm going to talk a little bit after about what we do. Before joining Isovalent, I work at Google. I did Kubernetes things. I'm still contributing for Kubernetes on autoscaling and networking SIG. I've done a lot for cluster autoscaling and gateway API recently. At Isovalent, my job is what we call the sales engineer solution architect. So I help our customer using Cilium eBPF and Cilium Enterprise. So today, I'm going to talk a lot, but if you have questions, feel free to raise your hand. We have like a manageable number of people, so you don't have to wait for the end. If it's like a small thing, like, oh, I don't understand, how does that work? If it's personal regarding your use case, then it's better to wait for the end. Every time I say Cilium during the presentation, it's Cilium OSS. So let's keep it transparent. Every time I say Cilium, it's Cilium OSS. If there is something in the presentation related to Cilium Enterprise, so what we do at Isovalent, I will always mention it. So I will say Cilium Enterprise. I have to, because some of the demo and stuff I want to show to you are very linked to that, and I want you to understand like the under-the-hood architecture of things, so I have to use the Enterprise version. But every time there is something that is Enterprise only, I will always told you. So Cilium is Cilium OSS, Cilium Enterprise is what we do at Isovalent, and eBPF, we're going to talk about eBPF. First, who have never heard about Kubernetes before? All right, who is not using Kubernetes in production? Okay, so not that much people. Who have never heard about Cilium before? Okay, who is using Cilium in production? Okay, eBPF, who has never heard about eBPF before? Okay, who is using eBPF in production? All right, still a few people. Okay, who is a Linux kernel developer? All right, that one always on point, okay. Very sorry for the few people who already heard that one, but you know, it's working. Okay, so let's start with the beginning. So I'm gonna do two things. I'm gonna move from slide to drawing. I have the drawing skills of a 2-year-old, so don't blame me, but it's helpful to explain like very hard content. So we're gonna start with the beginning and talk about eBPF, because that's at the beginning of everything I'm gonna mention today. I want this talk to be quite technical, so sorry for the non-technical people, but my understanding is that you're like mostly technical. If you don't understand something, that's your moment, so ask your question. So what is eBPF? I asked if we had some Linux kernel developer because it's hard. Like it's very hard to develop for Linux. So every time you want to add a new feature to the kernel, you have to find someone who knows the kernel and the huge code base of the Linux kernel, and then you have to find someone who is friendly enough with Linux to have a Git commit and a PR validated. It's like, it takes a lot of time. But that's why the word is still working. Like Linux is everywhere. So if you do a mistake inside the Linux kernel, you can basically kill people, like for real. So it's very, no pressure. So it's very hard to make any change to the Linux kernel. So what eBPF is a very, very easy way to improve and add functionalities to the Linux kernel. Who have already been using Lambda function or Cloud function, for example. You know, all this event triggering function in the cloud. So it's exactly that, but for the Linux kernel. So 2-year-old drawing time. How does it work? It's pretty easy when you think about it. So when you deploy on Kubernetes, you're going to interact with two things. What people call the user space and the kernel space. User space, do we have developer in the room? Developers? Developers? Yep, sorry for you. It's not personal, okay? So the user space is where developer play. You know, we let them play around. They can do whatever they want in user space. For example, they can deploy container. So you have Kubernetes running in user space, and you deploy a pod, and inside the pod you have containers. So let's say here I have my container. User land is a perfect land. It's like very, very easy to interact. You just deploy your container. But now, if your application needs to access let's say, a file because they want to write logs, for example. There's no way you let a user access a file system. First, for security, and secondly, because they're going to mess it, for sure. They're going to do something wrong at some point. So the way it works on the Linux kernel is that to open this file, you have to go through what we call syscalls. So it's function exposed to syscall. I also write like a 2-year-old. So it's exposed to the user space, but run inside the kernel space. So for example, if you want to read a file, you're going to call a syscall called open, and many, many, many other syscalls. And now you can have access to this file. You can open it. If you want to write, you're going to use another syscall. You're going to use the write function, for example. So see that as an interface when you want to do something that is lower level than what you're allowed to do in user space. And user space is safe because you can have you have a very small coverage of functionality of stuff you can do in user space. So now, what does it matter? Because if you understand that, then understanding eBPF is very easy. What the kernel developer did is giving us an API. So here you have the eBPF API. And through this API, we can inject binary code through higher language, for example, Go. So you can write Go code. And with this Go code, inject your binary. So that's like binary. And you inject that through the eBPF API, and you hook to one of the function, one of these syscall. So here I'm going to hook my code there. So what is happening is I'm saying to the kernel, every time this function happens, you're going to trigger my hook function. Pretty easy. So I don't have to recompile the Linux kernel. I don't have to wait to add another functionality. I can just, at runtime, inject the code that is going to be run every time this syscall is called. Does it make sense? Do I already lost someone? All right, one person, sorry about you. So it's like an event triggering system. Every time this event is going to happen, every time this function is called, then you're just gonna do whatever I ask you to do. It's like very, very easy. But the question is now, what do we do with Cilium? So Cilium is this. Cilium is this box here. So that's Cilium. It's just people writing Go code that is going to inject functionality inside the kernel to do stuff. And the stuff is networking inside the Kubernetes cluster. Pretty easy. So what do you do with that? So in my example, this is a syscall linked to a file system. But we have syscalls for everything, including networking. So for example, if you have a pod that is trying to send a packet, like an HTTP request, to another pod, they're going to have to open a socket. They're going to have to build this HTTP packet. They're going to have to call like hundreds of syscalls. So Cilium is injecting binary code to do any modification required to enable CNI functionality. So for example, let's say pod A is trying to talk to pod B. Let me do that. So let's say you have a pod, it's A, it's trying to talk to B. So what we're going to do is just listen to the syscall that is going to be called to establish a connection. So now I have my binary code, that's my binary code, and inside my binary code I can do many things before getting back here. I can do filtering, I can do, are you really allowed to talk to B? I can modify the packet. I can be, okay, but I'm gonna add like an HTTP header, for example, and I can even reroute the packet. So I can be like, oh, you want to talk to B? If you want to talk to B, you're first gonna have to talk to C. Or you have to be authenticated. Or if you want to talk to B, you have to use MTLS. And I can even do MTLS, like without service mesh and anything. I'm gonna mention that later. So all of this is happening, once again, inside the kernel space. So here, there's kernel space. Here, let me go back. And I want to, okay. So we started with doing a basic CNI implementation. Basic CNI implementation. So everything related to a routing packet, have an IP for your pod so they can talk to each other, everything you want from a CNI. But our customer, they wanted more. Obviously, because if you've been using Kubernetes in production, you know that, it's great till it's working, and when it's not working, then you cry. And if on top of that you add networking, it gets crazy very, very quickly. So we're starting with observability. So the possibility to see metrics, so everything related to networking metrics. We're going to talk a lot about that today. That's the topic of the presentation. But also flow visibility, so what I show you when I ask, can you read? So all of that was the flow, so all the requests happening on my networking cluster, on my networking stack on my cluster right now. So this is entirely managed through eBPF. We also have service dependency. So if I go, for example, here, you can have, let me find a bigger one. You can have access to the list of service and a service map of all your service deployed on your cluster. So you can see, so this checkout services is talking to the load generator, which is talking to the email services. You can see all of that back into the product without service mesh or, I don't know, sidecar or any type of proxy. And so we did everything around observability, and lastly, network security. So everything related to network policy. So once again, if I want to block a connection between A to B or B to C, I can do that with Cilium 2. I can write, it's not the topic for today, but you can write Cilium network policy to block traffic. This is enterprise, sorry, didn't mention. So on the enterprise version, you can create a network policy based on like live flow, like that, to like block some traffic and have like zero trust and all of that. Anyway. And also identity-based system and encryption. I'm going to talk about the identity-based, and then we're going to move into the Grafana export event and basically how does it work, and how can you use Cilium to provide more metrics and more visibility to your cluster. So let's talk about identity-based. I have one slide on that. Okay. But maybe I can, you know what, let me go back to this. I did that earlier. I'm pretty sure I can do it again. Okay. So let's talk about identity. So what happens when so let's say you're using basic kube proxy implementation of a Kubernetes CNI. What happens when you create the pods and you want them to be able to talk to each other or block any connection? Sorry? I can hear you. Yeah? Oh, no, I was not. I was not. But thank you for making sure I was not. Yeah, sorry about that. So yeah, I was thinking at the same time, like, what should I draw? Oh yeah. So you have pod A and pod B, and you want A to be able to talk with B. Pretty simple. So you're going to deploy a Kubernetes network policy, an L3 or 4 network policy, and be like, you know what? A is allowed to speak to B on port 80. That's when you're a developer. Developer, remember, easy life. Like A can speak to B on port 80. But now you're a platform engineer, and you have to understand, okay, so but what is happening right now? So what is happening under the hood is that every time you want to be able to write, this, you have to put labels on your pods, because a network policy, they don't know A. They need a pod selector. So you're going to see, okay, so on A, I put a label, it's app equal front, and on B, it's app equal back. Okay. So now your CNI understand that you want everything that has the label app equal front to be able to speak with everything that has the label app equal back. But once again, your CNI doesn't know about that. What they know about is IP addresses. So what it did, if you use, for example, kube proxy, which is like 85% of people, under the hood it's using either IP tables or IPVS, but they use the same implementation. They're gonna track every IP associated to every pod that has app equal front. So let's see IP1, IP2, and IP3. And they're gonna track all the IP addresses linked to B and be like, okay, IP4, IP5, and IP6. So then if you have a request coming in from A to B, this request goes through this, what we call IP chaining, IP tables, And they're going to say, OK, so it's IP1, and IP1 is allowed to speak to IP4. So far, so good. But now, you're Kubernetes users. You know that your developers are going to go crazy, and they're going to deploy a deployment, and they'll be like, you know what? They're going to go crazy with horizontal pod autoscaler, and they'll be like, you know what? You're allowed to scale. You can have 3 now. So at the moment you have 2 more, what is happening is that these got assigned IP addresses, and these IP addresses now, they have to go there, okay? So I need to add new IP addresses. IP, I don't know, 6 and 7. But this table exists on every node of your Kubernetes cluster, every node. So it means that every time there's a new pod, this IP has to be propagated on every node to be able to have this chaining working. Every time you apply a networking policy. So if you have 100 of nodes and 100 of pods, it means that every time there is churn, you have to rewrite the entire IP table's rules chaining, because that's just how it works, because that's the implementation. So obviously, if you are, I don't know, like Datadogs, and you have a Kubernetes cluster with 5,000 nodes and 200 pods per node, you can't use that. It's just not working. But even if you're a smaller user of Kubernetes, you might have faced this issue already. So that's why we have this identity system where every time you're going to deploy a pod, we're going to use this label, so app equal front, and we're going to use another hash map, and we're going to be OK. So all these IP address, so 1, 2, 3, 4, they are one thing, they are front. And all of this address, so 4, 5, 6, they are one thing, they are back. And our rule, instead of using IP, is just going to be an hash map saying front is allowed to speak to back. So every time there is a connection established between A and B, we just look at the identity of A, it's front, and then we know in the hash map that front is allowed to speak to back. So it's a very strong separation between networking, using IP, because IP is great, and security, using identity. And why is it useful? Because if I go back there to the service map I show you, if I go back here, there is no IP addresses. This is human readable. This is a Cilium identity. Like I can understand front end. Like once again, who were the developers? You can all understand front end, right? Joking. I still love you. So it's very, very easy to understand what's happening. So that's a very high-level overview of why people are using Cilium, why is Cilium everywhere, this identity system, the scalability of not using IP tables and IPVS. But we can do many things. If I go back there, we have service mesh capabilities. We have Hubble for observability, so we can replace Istio, but we also have load balancing, so you can replace HA proxy, Nginx, because all of that is just networking. Like it's supposed to be simple. It's supposed to be networking. Before we ask developer to deploy Istio, that doesn't make any sense. Istio is a platform thing. It's networking. It should be done by the platform. That's just my opinion. So now, talking about today's topic, what can you do more, and how can you use all of these metrics when you are a Grafana users? So let's draw a little bit. How much time do I have left? Sorry. OK, perfect. That should be enough. So how does it work? When you deploy Cilium, you're going to deploy multiple things. You're going to deploy what we call the Cilium agent. Cilium agent. It runs as a daemon set on every node. So that's the Cilium agent. Okay. You're also going to deploy Hubble, the UI. So what I show you, like the Hubble UI. Okay. And the Hubble UI need to read all of this. So all of these metrics that you show there. So for example, the flows, they need to read them. So the Hubble UI is reading from another component called Hubble Relay. You cannot see my screen because I'm dumb. All right, thank you. That was a test. And you failed that time. She was better the first time. So the UI the UI is connecting through Hubble Relay through gRPC, and the Hubble Relay is reading from all of the Cilium agent. Now, that's why I love drawing, because you cannot be like approximative. Like, what does it mean to say it's reading from the Cilium agent? So the Cilium agent is writing everything into file. So there's a lot of local files written down by the Cilium agent. And actually, if you look a little bit closer, it's not only by the Cilium agent. So the Cilium agent is a daemon set, but inside the Cilium agent, there's many things, many other processes running inside. There's no such thing as container, right? So there's multiple processes running inside the Cilium agent. One being an envoy proxy for everything related to L7, and another one being Hubble. I know, Hubble again. So this one, internally, we call that the Hubble server. So the Hubble server is going to write every metrics, but also, and that's important for you today, expose a slash metrics. So it means that you can use Prometheus to pull metrics out of the Cilium agent, but not really the Cilium agent, the Hubble server process running inside the Cilium agent. So that's very important because that's what we do when we have a very basic installation of Prometheus. You're just gonna have your you're just gonna have Prometheus reading to all of this. Oh my God, I put myself in this situation. Reading in all oh God, I did it again. Reading in all these slash metrics and pulling everything, and then you just have to use Grafana and reading there. Grafana. So this is the Cilium OSS setup. So if you use Cilium OSS yourself, so if tomorrow you use Cilium OSS, that's how it works. So the Cilium agent is writing everything into file, but Hubble is exposing metrics that you can query through Prometheus, and then you can use Grafana. But the set of metrics available here is pretty limited. So there's more into these files here. So if you want, you can also use, because it's file, so you can also use things like FluentD, for example, and you can read this file, and yourself you can like feed Prometheus or expose Prometheus. There's many ways to have FluentD working with Prom. And there's more metrics here. Last but not least, you can also directly query Hubble Relay. Why would you do that? Because Hubble Relay is connected to every Cilium agent, to the agent, all of the agents present on every nodes. So you can also directly query Hubble Relay like the Hubble UI. Oopsie, like the Hubble UI does. Lastly, Hubble UI is also writing everything into file. So it also means that, oh God, I did it again. Okay. So it also means that you can send all of this, once again, through FluentD to Prom, and then use Grafana and have access to everything. Why would you do that? That's a very interesting question. Let me show you a few examples of fun things you can do. So this morning I did a demo. By the way, I was using, oh my God, where is it? I need a proof. Because it's May the 4th. So that was a Star Wars demo, but you missed it. So we were on Endor, TIE Fighter, Death Star, sending query everywhere, pretty easy. And the idea was to see the traffic and have information regarding who is talking to whom and what type of network policy are you eating. So on this Grafana dashboard, I can see here at the bottom that I have both ingress and egress on my cluster. So request coming inside some pod and going outside, targeting other pods. And I can see what network policy they are eating. Why is this important? If you're working in a company that care about security, that's a very easy way to have this zero trust network policy, because right now what I did is deploying two network policy. I deploy the first one, that's the yellow, you can see here, the yellow. That's an allow all network policy. So everything is allowed on my cluster because I don't want to break production. But if something is handled by this allow all, then it generates this yellow line. And if I use another network policy, so a targeting network policy for other, then the yellow become red or blue if it's an L3 or an L7 network policy. So now I can take my computer, go to the developers and be like, so I can see that this TIE fighter is going to Disney.com and there is no network policy for it. So you have to write a network policy to handle this traffic now. And the developer is like, yes. And then 1 week after that, I go there and I'm like, so there is still this TIE fighter speaking to Disney.com. You have to deploy a network policy, but at least I know it. And when all of this work is done, and there is no all matching, but everything is matching a network policy, I can just delete this allow all network policy, and now I have zero trust. Because if something else happened on the cluster, I know for sure that it's going to be blocked. So only the traffic that is matching this network policy will be available. So that's one of my favorite use cases of exporting policy verdicts through Grafana dashboard and stuff you can do with that. Obviously, all of this would be possible using, I love the, oh God, sorry, port forwarding. Okay. So all of this would have been possible with this, but let's be honest, Grafana was a little bit easier to read. But it's doable then. Another Grafana dashboard I like is what people called the HTTP golden signals. So everything related to the life of a request. This is one of the top reasons. I was kind of shocked, but this is one of the top reasons why people are using service mesh. So there are people who are installing an entire control plane, injecting sidecar into every containers just to have metrics. Trust me, that's the truth. This and MTLS, potentially. But you can do both without instrumentalization. All of that is coming from eBPF. It's handled and generated by the kernel, and we just send everything through user space, through the Cilium agent, and then export it to Prom, as I show you here. Remember? Oh my God, it's ugly. And then I can read that from Grafana. So what do we mean by golden signals? Here I can have, for example, the volume of requests per second coming inside my cluster. I can have also the request of every HTTP request separated by pods on my cluster, the CPU usage per pods. I can also have, do I have that one here? Nope, but it's possible to have the CPU usage per pod per request. So you could be like, every time this pod is hitting this specific path with this specific header, I have a surge in CPU. So do something. This is like very deep dive in terms of like packet filtering. Once again, incoming requests per destination and per response code. Like all of that, you don't need to have a service mesh to be able to handle that because it's networking. So that should be part of your CNI and exporting to Grafana. And I have one last one. Everything I show you inside Hubble, oh my God, from black to white, that's painful for your eyes. I'm very sorry. I shocked myself. I was like, what's happening? So everything you see here is exportable. Some of it it's possible to export if you use the OSS version, but not all of it. Like there's a list of metrics you can export from Cilium OSS, and there is another list of things you can export when you use Enterprise. So potentially part of those dashboards will not be available to you, just for transparency purpose. But this service map is. So it's exactly the same. So if I go back, sorry again, one last time. If I go back to this service map, I've exported all of this information back to Prom, and I'm pulling from Grafana, and I've been generating this with what's the name of that? Graph map, sorry. So you can see here I have a little bit more information because I crossed the information of services with the metrics. So I can see here that my ad services is handling 6.3 message per second, and I can see from where, and other information regarding who is failing me, or the number of requests per pods, for example. And once again, all of that with absolutely no instrumentation, just using, so for this demo, I have an AKS cluster running Cilium as a bring your own CNI setup. And I just install Cilium on it, and that's it. You have access to all of that. I hope it was clear. Do you have questions? Tons of questions. We have time for questions. I try to give you time.
I have a question.
Let's go.
We have problems in our clusters that we have too many metrics with high cardinality. How do you fix, how much?
Yes.
How do these metrics have, how is the cardinality with these metrics?
Yeah, that's a very good question. So it depends what type of metrics. Every metrics related to the agent or L3, L4 is handled by eBPF, so it's in kernel space. And for these metrics, you can set up aggregation and filtering inside the kernel. So for this metrics, it's pretty easy, because if you don't ask for it, then it's not sent to user space. So you will never see this metrics, you will never get this information about it until you ask for it. But for every metrics related to L7, because it's coming from the Envoy proxy, which is already running in user space, whatever happen. Like filtering and aggregation will happen on user space. So I would say it depends what type of metrics you want. Yeah.
Thank you.
Can you run Cilium without Kubernetes?
Oh, that's a very good question. Yes, so the only thing we need is a Linux kernel. So, and we announced at KubeCon that we can also now mesh VM to a Kubernetes cluster. And we can even mesh VM that are not running Cilium with Cilium. Yes, I know. So very, like from high level perspective, how it works for, if you're interested by that, so let's say you're using Azure and you have like a VNet. What we're gonna do is deploy a VM inside this VM that is running Cilium and the agent is rewriting all the routing table inside this VNet to redirect the traffic to this VM, and then there's tunneling doing to like between the Cilium agent. But short answer is yes, you can use Cilium without using Kubernetes, but you need Kubernetes at some point because Cilium uses Kubernetes as a control plane. So short answer is yes, it's possible, but the real answer is you will need Kubernetes as a control plane, but you can then extend to VM that are not running Kubernetes, if it makes sense.
So it means that you have to run it with some public IP of some sort. You cannot run it in a local network, for example.
Yeah, exactly. In this scenario, in this mode, yes. I don't know what I'm doing wrong. Looks like it's just turned off. Questions? Sorry.
Yeah. Can we customize this matrix? Suppose something which is not So if we wanted to customize eyes we need or some parameters are not there.
Yes.
Is there any possibility?
Yeah. It's definitely possible. So it depends what type of metrics you want and what you want to modify. So there is two products actually. Cilium is one product, and there is another product called Tetragon. And if you are missing metrics from Cilium, then the way to extend the metrics is to use Tetragon. And Tetragon can go like very, very, very deep, like cipher into HTTP requests, this type of stuff.
And how about this matrix data is also available in Hubble UI?
No.
Okay.
Yes.
As you said, the data, move to Hubble UI, then we can create a file or something.
Yep. But you could do that the other way. Like you could feed your Prometheus yourself and not use the Hubble UI for this new matrix and use Grafana, for example.
Okay.
Yeah, that would be the way to go. But I didn't mention that because I'm using already an old version. Inside the new version of Hubble, you can import Grafana dashboard inside Hubble.
Okay. And what is the difference between your enterprise as well as the open source API?
So in terms of for Hubble or overall? Okay, so short because I'm not there to like sell enterprise, but just to understand the difference between enterprise and OSS is not in terms of functionality because we are an open source company. So 95% of our engineers, they do Cilium OSS. So what we do with enterprise is everything related to HA and production readiness. So let's say you have like L7 network policy, then you have one Envoy proxy per node. If this Envoy proxy goes down, then nothing is working on your N7 network policy, and it's passed through on your cluster. So with Cilium Enterprise, we have multiple NHA and stuff. So we don't want to block the community with like enterprise-only feature, but we provide production readiness and support. And the joy to work with me, which is selling enterprise. Gonna be honest, I'm the selling point. Other question? Nope. Great. Am I on time?
Yeah. Do you have stickers?
Do we have stickers? Yeah, so that's also how we sell enterprise. So just because I happen to have that open, this is the integration of, so it's not released already, but this is the integration of Grafana inside Hubble. So here I'm on Hubble, but those are Grafana dashboard. So you can do it both ways. That's also possible. Yep. Thank you.